Going on, everybody? What we're going to be doing today is we're going to be doing 10.4, but we're going to be doing it a little differently. So we're going to actually jump to number 8. So wherever you are in your notes, go ahead and get them out. We're going to jump to number 8. And your book was talking a lot about quilt modeling. We're going to show you more of the procedural way during this lesson during distance learning. So on a separate sheet of paper, before we get to number 8, I'm going to do this example problem. And I am going to teach you on how to rewrite something in standard form, and I'm going to teach you how to factor it if it's able to be factored without using the quadratic equation. So let's go ahead now and look at this. You have x squared plus 5x plus 6. And in the previous lesson, you learned how to turn some of these into perfect squares. Well, I'm going to show you on how to turn any of these into just two binomials that multiply to each other. And the way we do that is, first off, I always draw this little x to help organize my thoughts. And I kind of mentioned this before, but what we are looking for is two values that will multiply to a times c and add to your b value. Okay, so it's kind of like this little formula cheat sheet that I have over here. So when I look at my equation here and I see these, so I'm going to go ahead and look at this. And some of you might be like, well, most of these, my a value is just 1, so why do I need to even do that? True, but next lesson you're going to have these be different. A is going to be different than 1, okay? So a times 1, 1 times 6 is 6. And then I have my b value 5. So what are two numbers that will multiply to 6 and add to 5? So you think there's like 6 and 1, that would add to 7. And then you're like, oh, 2 and 3, that adds to 5. So 2 and 3, okay? So now what we are going to do in my next video, or on the next slide, these are like my b values. So what you're going to do, if you remember I have my equation y equals y equals x squared plus 5x plus 6. Now your ax squared value goes here, so I just have 1x squared. Then my c value here is just 6. And then you have the factors from the previous one. So we had a positive 2 and a positive 3. Okay? And we put them in this chart. And now what we're going to do is we are going to factor out values. So really quickly, you always have your 1x squared, you always have your bx's, so make sure the x's are attached. Then you have just your c value. So if I were to look at this, we're going to pull out this value right here. What can I divide out of both of these, okay? So if I had x squared plus x, what could I factor out of those? And they both have an x in common, so that would go here. So then right here, I'm going to look at this row. I have 3x plus 6. If I had 3x plus 6, what could I pull out of there? Well, they both have a 3 in common, so I'll pull that out. Okay? Now we're going to look at the columns. I'll use dark blue so we know here. If I have x squared plus 3x, oh, I know I can pull out an x out of both of those. And then if I have 2x and 6, I know I can pull out a 2 of those. That's what it's divisible by. So then you saw here you can rewrite this then as my two binomials. These are called factors of x plus 2 and x minus 3. Oops, x plus 3. That's what y equals. If you were to FOIL or multiply these two binomials, you'd get right back here. But this is what it looks like currently, okay? Some people say, hey, how do you know if these are positive? You always take the sign of the highest variable. So when I pulled out these x's, I know x squared is the biggest one. Oh, and that's positive. These are all positive, but let's pretend this was like a negative 6 right here, and you're pulling some stuff out. You're like, oh, it'd be positive 2x because this x is higher than just this constant, okay? So you always take the sign of the x squared if it's in play, then you take of just the x, and then finally, the constant really has no say. C value really has no say, okay? So now let's go ahead and look at these. So really quickly, guys, remember if we're talking about squares and quilt models. These we're talking about rectangles. This is my length. This would be my width. This would be an area. If I were to multiply these would just be an area of rectangles. So that's whenever you're talking about rectangles or squares in here. That's why. That's what they're talking about. But let's go and look at this. This is an unsimplified version of this. So if I were to add this together, I would get x squared plus 8x plus 15. And what we're going to do is we're going to use this model. I am looking for two numbers that multiply to a times c. Well, 1 times 15 is just 15. And please bear with me, guys, because this is going to be come in very handy in next module or next lesson when we're doing a times c, okay? And then it adds to 8. So when you think of this, you're looking for numbers that multiply to 15 and add to 8. So when you look at this, well, it's 15 times 1 and 3 and 5. And you're like, oh, 3 plus 5, that adds to 8. So perfect. I can put my values in my little square. So if I were to look at these now, I would have my little square. And then I would just plug in. I got my x squared. Then I got my c value. And then you got your little factors that you just got here. So you got 5x and 3x. So right here I can pull out on this column an x. Right here, between 5x and 15, you can pull out a 5. Now let's look at the row. We'll do this in light blue. These both have an x in common of the x squared and the x. I'm basically dividing them both out. And here it's a 3x and a 15, and a 3 is in common. So these are all positive values. So you just have the two lengths of this rectangle, or the two factors, written this in factor form. Looks like this. Boom. Okay. So we're going to do these for all of these now. So I'm going to add these up to get x squared plus 10x plus 24. So we are always going to have this little box. It's actually going to be in your notes next lesson, but it's just good to get in the swing of things. So this would be x squared. This would be 24. And now I need to find my factors. So is it 24 and 1? Is it 2 and 12? 6 and 4? All that fun stuff. And to figure that out, it's just 1 times 24, which is 24. And I got my b value 10. So what are numbers that multiply to 24 and add to 10? Well, that would be 6 and 4. So I got 6x and 4x, and it doesn't matter which one goes here. So right here, this has an x. These has a 4 in common. And then over here, this has an x. And in this column, it has a 6 that I could factor out. So then when I go ahead and have my two factors, I would have x plus 4 times x plus 6. All right, some of the orders are written in even more simplified algebraic code. Figure out what these entries mean by finding the sides of the rectangle, which is what we've been doing, that have that area. Use the sides of the rectangle to write an equivalent expression in factor form. All right, so equivalent expression is just rewriting this of the length times width, the parentheses that we've been doing. So what are two numbers that multiply to a times c? So 18, and add up to 9. Okay, well, let's see. What are the factors of 18? I got 18 and 1. I got 2 and 9. I got 3 and 6. Oh, 3 and 6 do that. So I have 3 and 6. So let's go ahead now and put these values. Just remember, if we didn't do that previously, this is my ax squared, this is my c, and these are my two factors with an x. So I always put these as like bx's, but they need to have the x involved. So here I just got my x squared, here I got my 18, and here I have 3x and 6x. So let's go ahead now, looking at my rows first this time. We'll pull out an x here, and here I'm going to pull out a 6. This one doesn't have an x, so I can't pull that out. Now in orange, these both have an x in common, and here these both have a 3 in common. So we've got x plus 6 and x plus 3. Now some of you are starting to notice, hey, are these just these values with an x? When you have a coefficient of 1, yes, that is true. But on every single one of these, I want us to get in the habit of plugging in here, because if this was a different coefficient, it'd be very challenging to do that, so that's the easiest way to figure that out. All right, so let's go ahead now and look at this. I am looking for numbers that multiply to 8 times c, so 1 times 10 is 10, and add to 7. And so if I looked at the factors of 10, I got 10 and 1, 2 and 5, and you're like, hey, that adds up to 7. So then when I plug these into my box, we're going to have our a value, which is just x squared, my c value, which is 10, and then my factors, which are 2x and 5x. So then when I pull these out here, I can pull out an x here, I can pull out a 2 here. Going kind of quick here, but you can see I pulled out an x, I can factor out a 2. Here I can factor out an x, and between 5x and 10, I can factor out a 5. So the lengths of this rectangle, so let's rewrite this expression in factor form, which is x plus 2, x plus 5. Okay, so I just turned this trinomial into two binomials that I'm multiplying together. Okay, so let's go ahead now and look at the next one. I'm going to have two numbers that multiply to 8 and add to 9. So two numbers that multiply to 8. So let's see my factors of 8. I got 8 and 1. Oh, I don't have to go any further because 8 plus 1 is 9. So we're good to go there. We got 8 and 1. So then when I plug these in the box, I got x squared, I got my 8, and I have my two factors of 8 and 1. And don't forget these have x's here. So when I start pulling these out, I have an x here, I have an 8 here, I have an x here, I have a 1 here. So then my two factors are x plus 1, x plus 8. Smiley faces. Okay, so let's go ahead now and do this one. And I actually want you to pause it right here. We've done a few together. I want you to go ahead and try 13 to the end. And then you're going to unpause it and watch me solve it to make sure we got it right. Okay, so go ahead and pause it now. All right, guys, so you should be good to go. These should all be solved now, and we are going to go ahead and solve them together. So two numbers that multiply to 8 and add to 6. Let's see, multiply to 8 and add to 6 would be 2 and 4. So since I have a coefficient of 1, you already know that just should be x plus 2, x plus 4, because that's what these are. Remember, that only is the case if you have an a value of 1. But let's go ahead and just show you really quickly on how to do this. We've got x, 2x, x squared, 2x, 4x, and 8. Here we can pull out an x. Here I can pull out a 2. Here I can pull out an x. Here I can pull out a 4. And lo and behold, here are those values right there. Okay? So what other relationships or pattern do you notice when you find the side lengths of a rectangle for a given area of this type? We kind of just talked about this. The pattern is, it's basically values will multiply to AC, add to B. And don't forget, this only occurs when A value is 1. All right, next lesson or soon after, you're going to see what's a little different. So let's go ahead now and look at a few more of these here. Now, this is a negative 9x. This is really into account because we're going to have to do a few clues here. That means that I'm looking for values that multiply to a negative 8, or excuse me, a positive 8. 1 times 8 is 8, and adds to a negative 9. So when you know these values, you have a negative answer. When you have two numbers that when you're adding together, you know you're getting a negative, and you know you have two numbers that when you're multiplying, you're getting a positive number. So you know that is only the case if both numbers are negative, okay? So that would give me something like a negative 8 and negative 1. Negative 8 times negative 1 is positive 8, and negative 8 plus negative 1 is negative 9. So now when I plug these in here, just so we can see this, because it'll help us in next lesson, I'm going to have x squared here, I'm going to have 8 here with negative 8x, and negative 1x. And this is the first time we've seen other signs. So right here, you always take the sign of the highest one. So if you want to look at the hierarchy, you take the sign of the x squared, and then you take the sign of the x, and then the constant's just there to hang out, okay? So looking at the x squared and the x, I can take out an x, and since the x squared is like the strongest, you should say, well, that's a positive, so we'll leave this a positive x. Now looking at this row, I got negative 1x and positive 8. When you pull this out here, they both have in common a 1. Then you take, is it going to be a positive 1 or a negative 1? Well, x is a little stronger than just the constant, so we'll put that as a negative 1. When I say stronger, I just means it takes precedent, okay? So let's go ahead now and look at these. I have an x squared and a negative 1x. So since x squared will take precedent, we'll just take the positive x. And here I can factor out an 8, and this x takes precedent over the constant, so it's a negative 8. So I'm going to have x minus 8, x minus 1. Those are my two binomials. All right, so now look at this. I have two numbers that multiply to a negative 15. But they are going to add to a positive 2. So when we think about that, when I'm multiplying two numbers and I get a negative answer, well, I know one's positive and one's negative. But when I add them together, I'm going to get a positive number. So I know my value, my bigger value is going to be positive. So when I add them, I end up positive. So when I just look at the factors, I got 15 and 1, I got 3 and 5, and you're like, okay, that's all I got. And I kind of have to play around with this. So I know the bigger one is negative, okay? So negative 15 and negative 5. Well, negative 15, excuse me, the bigger one is positive, the smaller one is negative. So when I add these together, I get positive 14. When I add these together, I get positive 2. And lo and behold, that's what I'm looking. So I know I'm going to have a positive 5 and a negative 3. Okay, so let's go ahead and plug these in now into my little fancy factoring square. This is my ax squared value, so it's just 1x squared. This is my c value of negative 15, and then I got my factors of here of negative 3x and positive 5x. So when I factor this out, I'm going to factor out an x here. Negative 3x and negative 15, I can factor out a negative 3. And then coming around this way, I can factor out an x, and then over here I can factor out a positive 5 to get the values of x minus 3 and x plus 5. So remember, guys, these are equivalent. This is factor form. This is standard form. All right, last one that we're looking at, multiplying two numbers that are negative. So I know one is negative, and I know one is positive. And I know the bigger one is going to be negative, and the smaller one is going to be positive, because when I add the two numbers up, they're going to add to a negative 3 and multiply to a negative 28. So when I look at 28, what do we got? We got 28 and 1. We got 14 and 2, 3, 4. So then we got 7 and 4, so on and so forth. So then when you look at these, I know the bigger one's negative, smaller one's positive, and when I add these together, I got negative 27, negative 12, negative 3, and you're like, oh, ding, 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 that's the one I'm looking for. So I got a negative 7 right here and a positive 4 right here. So I know some of you are kind of like thinking, oh, I already know my answer is x minus 7 and x plus 4. That is correct, but just as a quick reminder, because this will really help us out, next lesson, we need to know how to factor these out of our little factor square. So remember, this is always your ax squared value, so it's just 1x squared. And reminder, the reason why it's just these values, it's because our a value is 1 on every single one of these examples. So then the next one, I got my c value, and then my factors that we just got. So when I factor these out, I have a fly blowing in my face. I factor out an x, here I factor out a negative 7, here I factor out a x, here I factor out a positive 4 to get these values right here. Boom. Okay, just a few more. All right, so now we're going to go ahead and do these. I am looking for numbers that will multiply to 42, add up to negative 13. I know that they are both negative because they're multiplying to a negative 42. So when I look at the factors of 42, got 42 and 1, got 2 and 21, 3 and something, 15, no, 14, let's see, 4, 5, 6, and 8, got 8, there we go, we got 7 and 6, okay, and I know that they're both negative. So I know when I add them both, I'm looking for 13, and the only one that does that is 7 and 6. Boom. Cool. So let's go ahead then and look at this. We'll take the shortcut on this last one here, just because, why not? I'm sure you guys are tired. And then, oh, and that's my simplified answer. Don't forget, these are equivalent. This is just in standard form. This is in factor form. So a customer asks, hey guys, I want a area of x squared plus 7x plus 9. So what are the dimensions of here? And they're like, I don't think we can do that. And let's see if we're actually correct. Remember, we're trying to look for numbers that multiply to 9 and add to 7, right? So if I'm thinking about this, all right, I got 9 times 1, and then you're like, okay, I got 3 times 3. Do any of those numbers add up to 7? And it's like, no. Okay, so it says the customer service representative said she couldn't make that rectangle. So do we agree with this lady? Yes, we agree. Because the length and width would not fit those dimensions. It's basically saying, hey, I want to build a triangle with the lengths of 10, 1, and 1. Well, it's not possible. You can't have a triangle with a length of 10 and then 1 and 1. You can't have an area of a rectangle be this because the dimensions just don't fit. Just like this couldn't fit and form a triangle, okay? All right, guys, that's it for today. So if you have any questions, please let me know. Yeah, have a great night.